Hello everyone, welcome to another kinetic tutoring episode. Today we're taking a look at question 3 from the 2023 AP Calc BC exam. Question 3 of the FRQ, that is. So let's get straight into it. A bottle of milk is taken out of a refrigerator and placed in a pan of hot water to be warmed. The increasing function m models the temperature of milk at time t, where m is measured in degrees Celsius and t is the number of minutes since the bottle was placed in the pan. M satisfies the differential equation dm dt is equal to 1/4 times 40 minus m. At time t equals 0, the temperature of the milk is 5 degrees Celsius. It can be shown that m of t is less than 40 for all values of t. Part A says a slope field for the differential equation dm dt is equal to 1/4 40 minus m is shown. Sketch the solution curve through the point 0.05. So here we're just going to follow the lines that we are given, starting at this dot, like so. It should look something like that. It doesn't matter if it looks perfect or not, but something similar to this. That's how you do part A. Part B asks you to use a line tangent to the graph of m at t equals 0 to approximate m of 2. Alright, so we can see that these lines go up by increments of 5, where these lines go up by increments of 1. So at 2, we're going to be at somewhere around 20, it appears. So here, that's what I'm going to say it's going to be at. M of t is degrees Celsius, so we're going to say around 20 degrees Celsius. Now let's take a look at part C. Write an expression for d squared m dt squared, so the second derivative in terms of m, and use it to determine whether the approximation form part B is an underestimate or overestimate. And what you need to know for this part of the problem is that if the graph is concave down, CD, then it's going to be an overestimate. And if it's concave up, it's going to be an underestimate. So there you have that. So let's find out whether the second derivative is positive or negative. So here we have dm dt is equal to 1/4 40 minus m. When you take the derivative, the derivative of this is d squared m dt squared. The derivative of this is going to be 1/4 times negative dm dt. Negative dm dt is simply what we have here. So we multiply it back in, and you get that d squared m dt squared is going to be 1/16 negative 40 minus m. Or sorry, it's going to be negative 1/16 40 minus m. So there you have that. And here we can say that this part of the equation is negative, and since m of t is less than 40, this part is positive, and a positive times a negative is going to always be negative. Therefore, d squared m over dt squared is negative, meaning that it is concave down, meaning that we have an overestimate. Now, part D just asked us to use the separation of variables in order to find an expression for m of t. So all we're doing here is simple integration. So we get dm dt is equal to 1/4 40 minus m. We separate our variables to get all the m's on one side. Dm 40 minus m is equal to dt over 4. Take the derivative of both sides, or the integral of both sides, you'll get natural log of 40 minus m is equal to t over 4, and we need to add the plus c, t over 4 plus c. You could have added it on either side, but let's see what we get. M of 0, so when t is equal to 0, m of 0 is equal to 5. So m is equal to 5. So natural log of 40 minus 5, which is natural log of 35, is equal to c. So now we just plug this back into our equation, and we get natural log of 40 minus m is equal to t over 4 plus natural log of 35. And there you have it, guys. That's how you solve that problem, parts A through D. If you have any questions, make sure to leave them in the comments below. And if you learned something and or enjoyed the video, make sure to leave a like and subscribe. And I will see you guys next time.